This conference will now be recorded.
So within that, we had seen one problem also, right? This was the problem given, and this was just example. And here the formula is given. Uh, through this formula, we can calculate discharge, right? Through this, first we can calculate the velocity, right? Over the velocity over this area, for example, and suppose velocity is v1 here. This is for v2, v3 is for this one, v4 is, then v5, v6, and last is v7. Now, once we know the velocity and we know the area means area of this section, for example. So here it will be area will be say A1. So the discharge will be what? Q1 will be equal to A1 into V1. Similarly, so how many areas are here? 1, 2, 3, 4, 5, 6, 7. So we will get Q1 plus Q2 plus Q3, right? Q3 plus Q4 plus Q5 plus Q6 plus Q7. So we will get the total discharge, that is Q, right? This will be equal to Q. So here we will get the discharge in meter cube per second. Right, this we have already seen. So for this, actually, if velocity, the formula is available for this. This velocity is measured through the current meter, right? Through the current meter, and the data, the whole data is available for the from the current meter, right? From current meter, and current meter is what? Current meter is a instrument. Meter is an instrument which is used for measuring the velocity. Is this okay? Current meter is used for measuring the velocity, right? Now, so here you will see that. So we have already seen this, how it is calculated. Suppose we know the distance from the edge. For example, if this is the river, right, and there are the many areas. From left edge to this distance is given as a 3 meter, right? From this it is given as, this is 6 meter, right? Again from the edge, this distance is given as 9 meter. Likewise, this distance is given as 12 meter. So it means almost the breadth is equal to 3 meter for all, right? And the depth is also given. Once we know the depth, we know the area, we know depth, we know the breadth, we can calculate the area. So here, the confusion was that whether if we multiply this 1.4 with 3, we will get how much? 2 point, this will get 4.2, but here it is area is coming is 2.1. So how it comes? So here we had calculated 0 plus 3, right? And we had taken the average, sorry, 0 plus 1.74 divided by 2 multiplied by 3, right? We had calculated this 2.1. Is it okay? Just I am revising so that those who were late, they can understand. So how this area has come? We know the breadth, this is B, right? And this is depth, D. And how this depth has come? This depth is taken as 0 plus 1.4 divided by 2 is equal to 0.7, and this 0.7 is what? This 0.7 is our depth, and we know for the rectangle the area is b into d, right? So we multiply this b, that is 3 meter multiplied by 0.7, so we get 2.1 meter square, and this 2.1 is what? This one, right? Similarly, likewise, we can find this one, this one, this one. Now, after that, there is another problem is given. So here, just uh, the data is given. Estimate the discharge in a stream as shown. The current measurements, the current meter measurements are also given in the table. So see here, this is the formula. We can we should remember the velocity through current meter can be measured with this formula, and this formula is 2.3 into n is what? Number of rotation plus 0.05, right? Once we know this, what is n is the revolution per second. How many? Suppose this propeller is there, our propeller is there in the current meter, so it rotate one circle or complete one circle, right? So how many circle is completed? Suppose this is first, then second, then third. So in 1 second, how many rotation, how many numbers is rotated in what time? Means in seconds. Suppose this number is say 20 in I say this is 5 seconds, right? So we will put this value 20 here, and we can get the velocity. So here just we will calculate. Now the depth is given. The depth is given as 1.68, and breadth is given, say, distance from it. Suppose this is the river like this, right? Then how many sections are given? Like uh, 1, 2, 3, 4, 5, 6, 7. 7 areas will become 1, 2, then 3, 4, 5, 6, and 7, right? So here from left to this distance is given as 4 meter. Then again this distance is given as 8 meter. Then this distance is given as 12, and likewise, means every distance is of 4 meter, 4 meter, 4 meter. This is also 4 meter, 4 meter, and this is also 4 meter, right? Now the depth is what? This is the depth is what? Average depth is given. Suppose this is 0 and there is some depth. So 0 plus 1.68 divided by 2 multiplied by. So first of all we will divide it and we will get the depth. How much we will get depth? 0 plus 1.68 divided by 2. Can you calculate? Yes, can you calculate, student? Okay, just I will tell you one calculation, then remaining you can do. Sorry, this is already one thing. This this is already depth. Average depth is already given, right? Average depth is already given. Just we have to calculate the area. It is as simple as just this one. See here, depth is given, right? 1 point. This depth is given. And how we got area? We taken the average 0 plus 1.4 divided by 2 multiplied by this breadth. So we will get area. The same thing is here. 0 plus 1.6. Right. Yes, we will take the average. Okay. So here this is 0 plus 1.68 divided by 2. We will get depth. How much it will be? 0.84, right? Now this depth is 0.84. We know the breadth. This is B. This is our D. Right? This is D. This is B. D means that is average, not only this one. D means this is average. So here, if we will multiply this 0.84 multiplied by 4, we will get the area. How much we will get 0.84 multiplied by 4? 3.36. So here directly we can write it 3.36, right? No, no. Salim, just check your calculation. Just check your calculation. See what we are doing. This is 1.68. So 1.68 plus 0 divided by 2. Because if river is like this and this is given as a this depth is taken as a 1.68. This is taken as a 0. So when we will take, so we will get the average depth. Average depth means here it will be somewhere here, right? So 0 plus 1.68. 0 plus 1.68 divided by 2, we will get 0.84. Am I right? Then 0.84 will be multiplied by this breadth, that is 4. How much we will get? 0.84 multiplied by 4. 3.36, correct. So here we will get 3.36. Now we know 3.36. Current meter number of revolution is given, that is 18. So here I will put 18. And what would be the velocity? We know the velocity formula is what? Just we have seen in the previously, right? That is what? Here the formula is this one. 2.3 n plus 0.05. 2.3 n plus 0.05. This is 2.3 n. Right? Now we will check here now. The same formula we will apply here. So we will check this for first. 2.3 into n is how much? 18 plus 0.05. How much we are getting? Velocity. All of you getting same? What? 2.35. All of you getting same? All of you getting same? 2.3 multiplied by 18 plus 0.05 velocity. 41.45. Right? So here once again we will check. See here. So see, 2.3 into n. N is 0. Suppose just you check here so that you will get your solution. 2.3 multiplied by 0.24 plus 0.05. You get 0.602, right? Now after that, if you check here on the second calculation, they have taken as a 0.73. So 0.73 multiplied by 2.3 plus 0.05, 1.72. So likewise, now how he is taking 0.602 average, and here the velocity is taken as 1.37 plus 1.01 divided by 2. Yes. How this 1.37 is calculated here? This 1.37, because this average of these two is here, right? If you will check the average of these two, you will get this velocity. So initially you will put as it is. If you will take the average of these two, you will get the I think, is it clear what I'm saying? Is it clear to you what I'm saying? See, this velocity is kept as it is for average velocity. But when you will take the average of these two, you will get this one. 1.73 plus 1.01 divided by 2. 1.73 plus 1.01 divided by 2, you will get 1.37. Then again plus, if you will take 1.64 plus 1.33 divided by 2, you will get 1.48, right? This velocity. If you will take the average of these two, you will get this average velocity, right? Similarly, if you will take the average of, likewise, you will get, is it okay? The same thing we will perform here. Same thing we will do here. Same thing we will do here. Now, what? How much we got this here? What was the area? Just please repeat me. 0.84 multiplied by 4, 3.36, right? Now, and here n is what? Current meter. This is 18. So here 18 is here. I will put just 18. And what would be the velocity? We know that v is equal to 2.03 into n plus 0.05. I think this was the formula, right? So use this formula and tell me the velocity here. 2.03. Use this formula here. V is equal to 2.0, 2 point, V is equal to, yes, 2.03, 2.03 into n into n plus 0.05. So here we got what? How much? 41.45. So put this value 41.45. Now you will take as it is 41.45 here. Now how you will get the discharge here? We know that Q is equal to how much? V into A, right? So in the previous example, if they have taken the average velocity, the same we can also perform. 0.6, now we cannot understand from here because we can understand from here how they are getting 1.01 multiplied by the area is how much? 7.05, that is 7.1. They are not taking that one, so they are taking 1.37 multiplied by the area is 7.05. Yes, so they are taking the average velocity, this one. So similarly we will use the same thing, average velocity. So average velocity is how much? First is 41.45. So here we will take the average velocity for calculating the discharge. So 41.45 multiplied by area is how much? What was the area? 0.84 multiplied by 4, 3.36. 3.36. So here we will take 3.36. Then we will get the discharge. How much discharge we are getting here? 41.139.272. Okay. So here we will take 139.272 meter cube per second. Cubic cubic per second is what? That is meter cube per second only. Now next is what? Okay, here again I am deleting this because here the very small spaces are available. Now next is this is 57. Put this 57 here and tell me the velocity here. What would be the velocity? 2.03 into 57 plus 0.05. How much you are getting? 131.15. Okay, 131.1. Just I am writing 131.1. 131.15. Okay. Now, just please check calculation. Your calculation, is it okay? 2.03 multiplied by 57 plus 0.05. 100 and how much? 115.76. Correct. This is not 115. 115.76. 115.76. Right? This is 57. Here it was 18. Now, you know this V average. What was this here? V average was how much? What we had got previously? Average. What was the value? Can anyone tell me what was the value here? I forgot this. What was the value here? Yes. Okay, I will check once again. This was 36.59. And velocity was how much? How much it was? 41? Okay, okay. It was 41. Okay. So, see, have you checked the calculation? 2.03. Sorry, 2 point, how much it was? 2.3, sorry, 2.3, not 03, 2.3. N plus 0.05. Okay, I do one thing. Actually, here I'm unable to write. What I will do here, I will copy this and I will put here. Now here I would be able to write. This will be more comfortable for me. Now please now do here. This formula is 2.3 n plus 0.05 is equal to velocity, right? Here n velocity, n number, n is what? 18. So here I will put 18. Now put this value 2.3 for this, right? 2.3 into n is 18 plus 0.05. So we got this 41 point something. We got it 41.45, right? So we got here 41.45, right? So we will write as it is 41.45. Now discharge will be how much? Discharge will be 41.45 multiplied by the area. Area is how much? We had received area is 0.84 multiplied by 4, 3.36. So here we will multiply it by 3.36. So we will get the discharge. That is 139.27. Right? Am I right? Student, am I right? Yes. Okay. Now, second time I will put the value of this 57 and I will calculate the velocity. Can you tell me what is the velocity here coming? 2.3 multiplied by 57 plus 0.05. How much? 131.15, right? 131.15. Now, so in this case, we don't know here the what should be the average velocity here. No average velocity is taken. They have not taken. At the third, means at the sixth one, they have taken here average velocity. The same thing we will do here. We will not take a velocity here, average velocity directly. We will take here. So now tell me, the n is 34.5, right? Plus, how much you will get the velocity here for this? Put the value here, 34 point. Sorry. Put the value and tell me what would be the velocity here. Yes, here. In this case 2.3 multiplied by this 34.5 plus 0.05. 2.3 multiplied by 34.5 plus 0.05. 79.4, correct. Very good. 79.4. Now in this case, here we will take the average of these two. Average of these two means 131.15 plus 79.4 divide by 2, right? Because they have taken the same thing in the previous one. They have taken 1.37. How they are getting 1.37? 73 plus 1.01 divided by 2, right? Similarly, we will take the average of these two. So here we will take the average of these two. How much you are getting average of these two? 131.15 plus 79.4 divided by 2. How much you are getting? 105.275, correct. So here you are getting the average velocity is 105.275. Now here we will calculate the discharge. So discharge will be what? This 105.275 multiplied by the area. What would be the area here? So here what we will take? We will take the average of these two, right? Depth will be the average of these two, because when you will see here how much you are getting this is all depth is given 3.3. So 3.3 divided by 2, 3.3 plus 1.4 divided by 2 multiplied by 3. So we got 0. Similarly, we will take the C. What we are doing here, first of all, just please take the average of these two depth. Average of these two depth means what? 1.68 plus 33 divided by 2. How much you are getting? 1.68 plus 33 divided by 2. Is it? Are you getting my point? Yes. 17.34. Are you getting same answer? All of you same answer? Are you getting same answer? See, we are taking the average of these two. 1.68 plus 33 divided by 2. So we are getting the 17.34, right? 17. So I will put the depth is 17 point. Sorry, 7. Directly I will do the calculation. 17.34 multiplied by the 4. 4 because see, if our river is like this, right? Every depth, every breadth is taken as 4 meter. This is 4 meter, this is 4, 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 and suppose this last one is also 4. Total is 7, right? 7 means 1, 2, 3, 4, 5, 6, 7 areas are here, right? This is first, this is second, this is third, this is fourth, this is fifth, sixth, and last one is seventh one. So can you tell me the area? 17.34 multiplied by the 4. How much you will get? Directly, can you tell me the answer? 17.34 multiplied by 4. So I will write the answer directly. 69.36. All of you getting same answer? Okay, 69.36. Now calculate here. 105.275 multiplied by 69.36. 36. So you will get the discharge Q here. How much you are getting Q for this section? 105.275 multiplied by 69.36. 105.275 multiplied by 69.36. How much you are getting? Yes. The discharge you will get 7301.8474, right, correct. 7301. Just I will write 7301. 7301 point whatever it is, suppose 8 or 6, right? Now, next one is similarly you find here for this, this is 60, you put value 60, right? So you will get the velocity through using this formula. You will get the velocity for here, right? Once you will get the velocity, next you go to this point. Suppose you put this value 45, you will get velocity. Once you will get the velocity, you will take the average of these two. Okay, that is 138 point something, whatever. Similarly, for here you will get something velocity. What is this? 2.3 multiplied by 45. 2.3 multiplied by 45 plus 0.05. 103.55. Okay. So here you will get the 103.55. So here just I am writing 138.05. Here you are getting 103.55. You take the average. So you write here average. What is the average? 120.8, correct? Now you calculate the area. How you will calculate area? First you take the depth, average depth. 33 plus 6 divided by 2. How much? 33 plus 6 divided by 2. Well, you will get 19.5, right? 19.5 multiplied by breadth is 4, because this is fourth, right? Everywhere this breadth is 4. So you will get the area 19.5 multiplied by 4. You will get area, that is 78. Are you getting same answer? 78, right? So you will get 78 meter square, right? Now, once you got area, just you calculate the discharge. Velocity is how much? 120.8 multiplied by area is 78. You will get the discharge over here, right? You will get value. Similarly, likewise, you will understand. You will calculate this. Yes, student. Okay, this is 19422. So here that is 9422.4, right? So you will get here 9422.4 meter cube per second. Likewise, you can calculate for suppose this. So here for this one, you will calculate the first average depth, then multiplied by the breadth 4. So you will get the area. Once you will get area, now here you put value 60, you will get the velocity here. Then again you put the 51 here, you will get some velocity. You take the average, you will get the average velocity here. Once you know average velocity, we average multiplied by this area, right? Here, whatever the area you will get here, you will calculate this discharge. Is it okay to all of you? Is this clear to all of you? Now, so this is one of the method. Now we come to the another slide. There is another method, that is the third method. It is area slope method. In the fluid mechanics, actually, this description is given for this method. What is this actually? We will try to understand this. See, suppose there is a hill, right? And within this hill, one river is flowing through this hill, right? River is flowing. So to find out the discharge for this river, so the method is slope area method, right? Slope area method. So how we find the slope, this discharge through this slope area method? If we will see the background of this, like now, if I will see this section, if I will see this whole section means this section. So this is what actually, if I take one section here, I take another section here, right? And if there is a datum line, some datum line is here, right? Just so this is datum line, and I say that river is say flowing. River is this is the bed of the river, right? This is the bed of the river, and here this is river actually. This river is flowing. I say that from datum is this is datum. This is datum. And from datum, this is datum line, or we can say reference line, right? From reference line, the bed of the river is, we said this is section 1, this is section 2, and this is said Z1. Z1 is what? Potential head. Similarly, here I consider it is very small Z2 from reference datum line. This distance is Z2, the bed of the river at section 2 to the datum line is Z2. Now here I say that the depth of the water in the river is say, here it is say Y1 and here it is say Y2, right? And if we add something means what? How much? If we add P1 square upon 2G at section 1 here, so we will get this is what? Total energy line. Total energy line at section 1. Similarly, if we will add V2 square upon 2G, then we will get the total energy line at this point. Now, if you will see, if you will observe that, if I will draw the horizontal line, then you will find that this much height is lost. This is called as head loss. And this head loss is of two types: head loss due to friction and head loss at exit, right? So based on this concept, the equation is derived, and this equation is this one, this equation, right? The same diagram is given here, right? So through this, what we calculate discharge at the section, right? This section, this is section 1, this is section 2. So through this, we calculate the discharge, where this Q is what? The Q is what? Discharge. And this discharge is in, the formula is 1 upon N A into R raised to the power 2/3 S raised to the power half. This is what? Now, what is S, what is R, what is A? If uh, I'll tell you. Now, suppose the section is here. Suppose this is the river section here. If we will see from front, it will look like this. And if I will say you this portion which is in water, this portion, this is called as perimeter. This is called as perimeter, right? And we know, if we know the area, this whole area, and this portion, this bottom, which is bottom portion, this one which is filled with what? This only this line, what I'm saying. Uh, just try to understand this. This line only, this line, right? This is called as perimeter, right? This is called as perimeter, and it is represented by P. And if we know the area of this river section, cross section, if we know the cross sectional area, so R is what? R is equal to area upon perimeter. This is the formula. What is R? R is the hydraulic mean depth. Hydraulic mean depth. In this formula, this R is what? This R is what? Hydraulic mean depth. But what about S? Or it is also called as hydraulic radius or hydraulic mean depth. Now, what about S? S is what? Channel slope, or it is also called as energy slope. See, when you will see this this channel is suppose flowing from upsides to upsides, upside or upper level to lower level, right? Lower level. So this is what? This is the bed of the river. This bed will have some slope with horizontal. So this is what? This is SF, or it is also called as S0, or sometimes it is known as S, right? Or it is say S. Is this clear? So this is what? This is the bed slope with horizontal. This is S or SF or S suffix 0. This is called as bed slope, right? Now, so once if we know everything, so we can calculate the discharge. Now, what about the N value? What is this N? This N is what? Manning's roughness coefficient. Means what? See here. Suppose this is our channel, right? You might have seen that this channel, water is flowing, suppose, from this channel, right? And one channel is also here, this one, and water is also flowing with this channel. So this is actually artificial. Artificial channel means this is, we can say, canal, right? Which is made with some human being, right? Made by human being, and this is the natural channel. So here the characteristics of the, suppose the characteristics of this bed means there will be some soil, right? There will be some, maybe there may be some stones may be there, right? There may be some another like grasses may be there. So what will happen due to this? The friction will be there, right? More friction means the N value is more, like 0.5 or 0.6, right? Or maybe 0.7. But this is man-made channel. So here the bed is with some smooth will be there. Bed will be some smoothness. It will have some smooth smooth bed, right? So here the n value will be very small, right? Like 0.1 or 0.05 or maybe 0.04 likewise, right? So this n value depends on the material which is present or physical condition. That's why this is called as coefficient. So once we know this everything, so we can calculate the discharge over the river. So for example, if somebody says if you have a river in the mm, in Oman, suppose there is a river, one river is flowing. Suppose here is some one river is flowing, and right, somebody says that can you calculate the discharge Q for this with slope area method, slope area method, then how you will calculate this? So first of all, the question is what is the slope? Means slope means what is the if you have studied the surveying, you will calculate the RL of this point. Suppose this point is A, and at this point I say this point is B. So if you know that the RL of this point and RL of this point B, this A, suppose this is 300 and 300 meter RL, and this is say 200 meter RL, right? Means the level of this point and this point is known to you, right? So you can, through this you can calculate the SF, or we can say bed slope, right? Bed slope. Is this clear what I'm saying? Now, second thing will be required. What is the n value here? So n value will be generally given for the different types of material. So it may be in the range of 0.05 to 0.1, right? Or maybe 0.2 to 0.3, likewise, for different types of material. Next one is what would be the area of this channel section, only this. What would be this area? So you have to calculate this area. If this area is whatever area is known, then you must know what would be the perimeter. Perimeter means whatever portion which is touching here to the water. This one will be the perimeter. Once you know this perimeter, you can calculate the R value. How area upon perimeter, you will calculate the R value. Next, you know N value, then you know S value, so that you can calculate the discharge. 1 upon N, R raised to the power 2/3, S raised to the power half. So through this method, you can calculate the discharge. Is it okay to all of you? Is it okay to all of you? Is it okay to all of you? Yes. Clear, very clear. I think it is clear to you. All of you, it is clear. Now, okay. Now I will come to another method, that is the, so see, for example, if I give you one numerical on this, for example, the numerical is given, determine the discharge, determine the discharge Oh my God. Once actually something happened. Just wait, student. One. Okay. Now, for example, the question is given: determine the discharge for the river of cross-sectional area 5.5 meters square and the bed slope of the river is 1:2000 and Manning's coefficient. See, Manning's is who is Manning's? Manning's is the scientist. Okay, Manning's coefficient. Manning's coefficient means n value. Manning's coefficient is 0.05, right? And the weighted perimeter is 20 meter. So what is given in the problem? See, we have to find the discharge. It is asking that find out the discharge Q. We know that Q is equal to what? 1 upon N, R raised to the power 2/3, S raised to the power half. See, first of all, we will write down the given data. For example, given data means what? Just I am telling you, area is given as 5.5 meter square. Perimeter means P is given as 20 meter. Bed slope S is given 1 upon 2000. So 1 upon 2000. So we will calculate 1 upon 2000 means 1 divided by 2000. This is what? 0.0005, right? And Manning's coefficient is 0.05 given. So just we will put the value, we can get the discharge rate. Is it clear to you? So we will get the discharge. We will get the discharge 1 upon n. N is 0.05 multiplied by R. We know that what is R value? R, the formula for R is area upon perimeter. So area is given as 5.5 divided by perimeter is given as 20 raised to the power 2/3, and bed slope is given direct 1 by 2000. We can directly put, no problem, 1 upon 2000 and raised to the power 1 by 2. So through that we can calculate the discharge. Is it okay? So this type of problems may be there, so you must be able to solve this, right? Is it okay? How much will be the answer? How much will be the answer? 5.5 divided by 20 raised to the power 2 divided by 3 multiplied by 1 divided by 2000 raised to the power 1 by 2 multiplied by 1 divided by 0.05. So the answer will be around 0.011 meter cube per second, right? Am I right? So you can check the calculation. Likewise, we calculate the discharge for any river. Is it okay? This method is clear. Yes, it must be clear to all of you, right? If it is not clear, again we can see this, we can solve the problem. See, 1 upon n r raised to the power 2/3 is raised to the power half 1 upon 0.05 into r is equal to area. Area means area upon perimeter raised to the power 2/3 1 upon 2000 raised to the power 1 by 2. If we will solve, we will get around 0.01 meter cube per second. So this will be the discharge. The next method is, so should I continue? Because yes, I, right? Am I continue? Just one, and one method is remaining. One or yes. Uh, should I continue? Okay, whatever we have covered. So in the coming Wednesday we have a quiz. So please prepare up to this part, up to 17 slide, right? After the midterm exam, whatever we have covered, that will be in the examination. Your quiz, I mean quiz 2, right? Is it okay? See, the quiz will be of, so we have a quiz 2. Marks will be of 20 marks. And after mid up to today, right? After mid up to today, that is your syllabus, right? And multiple choice will be there, multiple choice. So there may be the theory means plus numerical, all will be optional. So options will be given to you, multiple choice will be there. And the last thing is it will be on the Moodle, right? And the time will be around 1 hour and 20 minutes. Any doubt is there? So 20 marks, so 20 question, then it will be converted into 10 marks. Is it okay, all of? So here I stop.